and see how long it takes. Well, the first thing I'm going to do is declare a global variable. We'll call it words, and set that equal to the return value of a Python function called set, which essentially gives me a set object wherein I can store a whole bunch of words without duplicates. Python's going to manage all of that for me. In effect, it's going to implement what I needed to implement myself in problem set 5, a hash table. Now, down here, I'm going to go ahead and define a function called check, pass in as input a parameter called word, because of course that's how it was implemented in C. But notice the difference already. In Python, we use a new keyword called def to define a function, and we don't have to specify the type of the variable being passed in, word in this case, and we also don't have to specify a return type for the function. Now, inside of this check function, it suffices to do this. I'm going to return word.lower in words, which is effectively a Boolean expression asking, is the lowercase version of this word in the set? If so, return true. Otherwise, return false. Done with the check function. Now let's go ahead and define another function called load, which recall took an argument of the dictionary that you want to load into memory. And let's go ahead now and do this. With open dictionary as file, which effectively opens the dictionary, as in C we use fopen, in Python we use open, and it gives it a variable name of file. Then once that file is open, I'm going to go ahead and update that entire set of words, which starts out empty, by taking the file, reading the entire contents, top to bottom, left to right, and splitting all of the lines therein on the new lines that terminate each of the strings, effectively updating the set with every word in that there dictionary. Then I'm going to assume that it all just worked, because there's a lot less effort for me to perform myself in Python, and I'm just going to go ahead and return true, capital T, in Python. Done. Next, let's go ahead and define that other function from problem set 5, size, whose purpose in life was to tell me the size of the dictionary I had loaded. Well, in Python, that's pretty easy. I can just return the length, or len for short, of the set in which I've stored all those words. Done. And then lastly, I'm going to go ahead and define an unload function, which recall was responsible for freeing any memory I myself had allocated. I don't seem to have done any of that in Python. In fact, that's managed for me now. So I'm going to go ahead and simply say return true, because there's no work to be done. And that's it. In like 19 lines of code in Python, most of which are blank lines, I claim I have re-implemented problem set 5 in Python. Well, let's take a look now at the difference. I'm going to go ahead and reopen my terminal window, and I'm going to go ahead and maximize it so we can see more output. And now I'm going to go ahead and run in Python. Well, let's take a look now at the difference. I'm going to go ahead and reopen my terminal window. Blank lines, I claim I have re-implemented problem set 5 in Python. Well, let's take a look now at the difference. I'm going to go ahead and reopen my terminal window, and I'm going to go ahead and maximize it so we can see more output. And now I'm going to go ahead and run Python, which is going to be not only the name of the language, but the name of the program we use today to start running our Python code. And I'm going to run it on stellar.py, which I brought with me today, specifically on the largest of problem set 5 files, homes.txt. Enter. And as with problem set 5 itself, we'll see a whole bunch of is going to be, let's take a look now at the difference. I'm going to go ahead and reopen my terminal window, and I'm going to go ahead and maximize it so we can see more output. And now I'm going to go ahead and run Python, which is going to be not only the name of the language, but the name of the program we use today to start running our Python code. And I'm going to run it on stellar.py, which I brought with me today, specifically on the largest of problem set 5 files, homes.txt. Enter. And as with problem set 5 itself, we'll see a whole bunch of misspelled words being printed to the screen, some of which might very well be misspelled, some of which are just not in the dictionary, some of which are simply possessives of words that are in the today, specifically on the largest of problem set 5 files, homes.txt. Enter. And as with problem set 5 itself, we'll see a whole bunch of misspelled words being printed to the screen, some of which might very well be misspelled, some of which are just not in the dictionary, some of which are simply possessives of words that are in the dictionary. But at the very end of this output, the difference loaded. Well, in Python, that's pretty easy. I can just return the length, or len for short, of the set in which I've stored all those words. Done. And then lastly, I'm going to go ahead and define an unload function, which recall was responsible for freeing any memory because there's no work to be done. Specifically on the largest of problem set 5 files, homes.not spell checker in Python. Enter. And we see some of the same output. Reach problems where C is, of course, compiled. That's why your code we used in problem set 4 and how to apply a number of Instagram-like filters there too. Well, now let's go ahead and implement maybe one of those filters, the blur filter, whose purpose in life is just to blur this image. Well, let's see how long this takes. Let me go ahead and open up, say, blur.py, which is now going to be a Python program for blurring images. It's empty initially, but I can pretty much write this quite quickly now. Let me go ahead and at the top of this file, write the Python keyword from PIL for Python image library, import a object called image and another one called image filter. In particular, two features of the Python image library that's going to make it so much easier to actually solve. And then let's go ahead and define a variable. We'll call it before, representing the before version of this image, and set that equal to image.open, quote unquote, bridge.bmp, where that, of course, is the name of the file we want to blur. Then let's go ahead and create a variable called after, representing the after version of this same filter, and set that equal to before.filter, open parenthesis, image filter.box blur. And then just to be a little dramatic, I'm going to blur it more so than you needed to in problem set 4, but we'll see it more visibly now on the screen. Let's do an argument of 10, and then at the very end of this process, let's do after.save and save it in a file called, say, out.bmp. Done. So in just 4 lines of code, I claim I blur.py, cross my fingers as always, and indeed, I've made a mistake. Perhaps even if you've never written Python before, you can see it, and in fact, we'll see a number of these errors, some intentional, some unintentional, but on line 4, what I intended to do was set equal to before.filter, that variable I created called after. All right, that's all right. Let's go back down to my terminal window, clear it, to get rid of all that, and rerun Python of blur.py, cross my fingers even harder this time. Nothing bad seems to be happening. Indeed, now let's go ahead and open up out.bmp, and before we reveal that, let's go back to the original, which is bridge.bmp, and happening. Indeed, now let's go ahead and open up out.bmp, and before we reveal that, let's go back to the original, which is bridge.bmp, and now, dramatically, let's see the blurred version thereof. Voila, hopefully to your eyes too, it looks quite a bit blurry. Well, how about one more flourish? Those of you who were feeling more comfortable last week and implemented perhaps edge detection in C. Well, let's see if we can whip that up quite quickly too. Let's go ahead and write a file called edges.py using that same bridge.bmp file. And in this file, let's go ahead and do the following. As before, from the Python image library, let's import the image feature and the image filter feature. Then, as before, let's create a variable called before, set it equal to image.open, passing in bridge.bmp. So far, the same as before. Now let's create a variable called after, set it equal to before.filter, passing in this time image filter.find edges, which is different from box blur, and by definition, it's going to find the edges of this here image. And then after, as before, let's do after.save of out.bmp and just clobber the version of the blurred file that we just created. All right, that's it. Let's go ahead and open up my terminal window now. Let's go ahead and again run Python, but this time on edges.py. Cross my fingers real hard. So far, so good, and that was quite fast. Recall that the bridge.bmp image looked like this, but now when we open up this new and improved version of out.bmp, thanks to Python in just 4 lines of code, we now have all of our edges detected. So what can we then learn from C itself? Well, C had, of course, functions, and functions were those actions or verbs that simply got work done. And let's go ahead and compare side by side, much like we did with Scratch and C, the ideas that today onward are still going to be the same, and how they could translate to Python. So on the left here, we'll now have our friend Scratch. This, of course, was one of the first puzzle pieces we saw. It's a purple puzzle piece saying say, and it was a function insofar as it said the value of its argument, which in this case is hello world. Well, we've already seen in Python what this looks like. It looks similar to the version in C, but it's no longer printf, there's no longer a semicolon, and there's no longer an explicit new line. So in Python, it's quite simply this. Meanwhile, in Python, there are a whole bunch of libraries as well. Now in C, we had simply header files, and those header files give you access to the prototypes of, that is the signatures of the functions that you want to use from those libraries. Python uses somewhat different vernacular, whereby Python has what are called modules and packages. And a package is just a collection of modules, but a module is just a library using Python speak, so to speak. So anytime you hear someone discussing a module or a package in Python, they're just talking about using a library. And that library might come with the language itself, just built in as standard, or it might be a third-party library that you might download and install yourself, much like I did a few weeks back when we installed the cow say program so that I could actually have a cow or other animals on the screen display text. So in C, recall, we had something like this, include CS50-H, which was a header file pre-installed for you somewhere, but we will have, for at least this week, an analog of the CS50 library in C also in Python, just to make this transition from C to Python a bit easier. These two, though, are meant to be training wheels that you can take off and should take off even within a week or so. It's just meant to smooth that transition and make clear what's the same and what's different. So in the CS50 library, for Python, we also have a function called getString, whose purpose in life is to get a string. To access it, though, you don't use hash include CS50.H, that's a C thing. In Python, you would say from CS50 import getString. It's a little more verbose, but it's also a little more precise as to what you want from the library, especially if you don't want the whole thing loaded into memory. So here, for instance, is now a Scratch program that was a little more interesting than just printing out hello world. This was the first program we wrote that actually got some user input. So in fact, let me go back to VS Code, and let's see if we can't resurrect this C program real quickly in the form of a new hello.c. So I'm going to run code of hello.c. And then in my code tab, I'm going to do include CS50.H, include standard.io.H, and then below that, I'm going to go ahead and whip up our familiar version of this in main void, and then inside the curly braces, we'll bring back string, even though we now know it's char star. We'll call our variable answer, set it equal to getString, ask the user, quote unquote, what's your name, with a space just to move the cursor over. Still need my semicolon in C, and then after that, recall back in week 1, we did hello, comma, %s, \n, and then plugged in the variable answer, so it's to see hello David, hello Kelly, or something else. Just to be safe, let me do make hello, all is well so far, /hello, type my name, and this version in C seems to be working okay. So in C, these lines of code here translate pretty literally to what we just saw, although we got the answer variable in Scratch for free. That blue puzzle piece just existed without our having to create it, but it's a decent number of hoops to jump through in order to just get user input and print it out. Well, in Python, this is going to get a little more succinct in that the Python version of this code is now going to look like this. Printf is now print, the semicolons are gone, and what else seems a little bit different? Yeah. I don't need any placeholders. Yeah, so we don't need the %s anymore. In fact, I'm curiously using a plus, which if some of you study Java or some other language, you might have actually seen this before. Even if you've never seen Python before, you've only seen C in CS50, you can probably guess what the plus is doing, even if you don't know the technical vocab. What is the plus probably doing here? Yeah, so it's concatenating or joining together the thing on the left with the thing on the right. And we actually had that vernacular in the world of Scratch. We had the join puzzle piece that joins hello, comma, space, and the value inside of answer. A plus in Python can do exactly the same thing. So it's a little more user-friendly than having to anticipate, let's put the placeholder here and then come back later and plug in the variable. Humans over time just realized that it's a lot easier to sort of do this in this way than bother with placeholders. Though you can still use placeholders for other purposes. Another subtle difference between the C and Python version of these two lines. More subtle than that. What's missing? Yeah, I'm back. So \n is again gone for Python, so that sort of happens for free. Indeed, and one more difference. Yeah, we don't need to declare the type of answer. Recall that if we rewind, in the C version, you needed to tell the compiler that this is a string. And last week, we could have changed string to char star, but we still had to tell the compiler what data type we're putting into that variable. In Python, we can now get rid of that data type, and Python will just figure it out from context. If getString returns a string, well, then obviously the variable should store a string. If a function returns an int, well, then obviously the variable should store an int. And the language is just doing more of that decision-making for you, just to save you time and save you thought. There's a subtlety here, though, where we can make this program a little bit different. In fact, let's whip it up first in Python. Let me go back to VS Code here, clear my terminal, and let's go ahead and create a program that, again, called hello.py. That'll open up my previous version thereof. And just so we can see these things side by side, I'm going to drag that tab over to the right of VS Code and let go. And now you can see the C version still on the left and the Python version at the right. What I'm going to do here now in my Python version is change it to be quite like the version in C now at left. So as promised, I'm going to do from CS50 import getString. Then below that, I'm going to say simply answer equals getString, quote unquote, what's your name, question mark space, no semicolon. But then on the next line, parenthesis. Then on the next line, I'm going to do print, quote unquote, hello, comma, space, close quotes, plus answer. Down here, I'm going to go ahead and run Python if hello.py again, no compilation step. I'm just going to interpret it line by line. What's my name, David? And it seems now to work exactly the same. Now it turns out in Python, there's even more ways to solve problems like this, even trivial problems like this. So here we're using the plus sign, not as addition per se, but as the concatenation operator, the join operation. If you want, though, you can take advantage of the fact that print in Python can take more than one argument. It can take 2 or 3 or 4 or even 0 by simply changing the plus to a comma, getting rid of that seemingly superfluous space, and just give print 2 things to print. Because it turns out, per the documentation of print, which we'll eventually see, it knows that if it takes 1, 2 arguments by default, separate them for you by a single space. And that's something we can override as well. Which one is better? I don't know. They're sort of equivalent. It's such a trivial difference, but it speaks to the flexibility that you'll start to have, whereby the language is a little less rigid than C was, certainly when it comes to printing strings. So in fact, if I go back to VS Code here, and I go ahead and change that plus to a comma, and get rid of the space inside of the quotes, I can rerun Python if hello.py, type in my name, and we see exactly the same result there. But we can take this one step further, even though it's going to look a little cryptic. This is sort of the more Pythonic way to do things, and that too is actually a term of art. To do something Pythonically is to do it the way that most Python programmers would do it. It's not the only way, it's not necessarily the right way, but it's sort of the recommended way in the community. So here we have that latest version where I'm passing 2 arguments to print. The first is quote unquote hello comma, and then the second of which is the value of answer. I could similarly write this same program with this crazy syntax. Takes a little getting used to, but it turns out it's actually kind of nice overall. What's obviously different? Well, one, there's these weird curly braces are back. They're not part of the logic of the program. They're literally inside of the double quotes. But you can probably guess what this does for me, because there's one other crucial difference. What else has changed between before and after? Yeah, there's this weird F, which is not part of print F. It's actually inside of the parenthesis and next to the double quotes. And even this one this came out was a little weird looking to people, but this is how you get this thing to be a formatted string, aka an F string, as opposed to it being just a literal string of text. Now you can probably guess what it means to put the variable's name inside of the curly braces. It means the value of that variable is going to be substituted right there, similar in spirit to the %s in C, but a little more explicit. With the %s, you had to remember that that %s corresponds to this variable's value or something like that, which was just annoying if anything else, if anything. But this time, you have a placeholder in curly braces that just says what you want there, that particular value. And what this means more technically is that the answer variable will be interpolated by the interpreter, which means its value will be plugged in right there. So let's try this. Let me go back over to VS Code, and quite simply, on my last line of code here, let's change the input to print to be quote unquote hello, comma, and then curly brace,